All right, we can get started. Let's take a look at this first one that you submitted. Um, all right, so it wants to know what system is represented by the line shown. So one way to go about it, which is probably not how I would do it, is you could use Desmos. The issue with Desmos is um, you'd have to plug in each system individually and just like look at Desmos and see if it looks like this. So it'll certainly work, but there is what I think is like a quicker and kind of better way. But in order to do that, I want to go over kind of a different concept. So let's imagine I'm going to make up a different problem. Let's say we had something like this, like 3x um, plus 5y equals 30. So this is in standard form. If something is in slope intercept form, that makes it really easy to graph because we just have the intercept and the slope. Here, to get it in the slope intercept form, we'd have to rearrange. But the reality is on the SAT, I really not want to do any rearranging at all. I always want to work in the form that I'm given it. So for lines, that's y equals mx plus b, and then here standard form. So another way to go about this is to just figure out what the intercepts are. And so a general concept is that if I want to find the y-intercept, I make x 0. And if I make x 0, this disappears and I'm left with 5y equals 30. So therefore y is 6. And then if I want to find the x-intercept, I make y 0. So if I make y 0, this goes away. I'm left with 3x equals 30 and x equals 10. So when something's in standard form, we should be able to find the intercepts immediately. So even now you shorten this to just, if I want to find the x-intercept, it's just this number divided by this number. So in general, the ax plus by equals c, it's just c divided by a. And if I want to find the y-intercept, it's just c divided by b. So the reason I go through all that is if we can do that quickly, then this becomes a problem that I can check pretty easily. And I look at, first of all, I need the x-intercept of both to be 8. Well, if I look at answer choice A, 32 divided by 8 is 4, so that answer is wrong. So again, I'm doing C divided by A. I need to get 8 for both of them. If I look at B, 32 again divided by 8 is 4, so that one's wrong. If I look at C, 32 divided by 4 is 8. I get that in both C and D, so they work for now. And then I also need the x-intercept to be 8 um, for the second one, but they both work for that as well. Negative 64 divided by negative 8. So now I'm just looking at the y-intercept. And in reality, I just need them both to be positive. So if I look at C, 32 divided by negative 10, that's not a positive number, so that's wrong. So the answer has to be D. Right, so obviously it took a while because I wanted to like explain this concept, but if you start seeing it as in something's in standard form, if I just divide the C value, the constant, by the coefficient, that finds that intercept. And then I'm just looking at this graph as I just need to make sure the intercepts. And I feel like you could probably run through that more quickly than throwing each of these into Desmos.
All right, makes sense.
Cool. Okay. Number two, looks like a proportion problem. So we've got 803 voters, and according to the poll, we have this many people voting, and it says how many votes would Angel Cruz be expected to win? So they're talking about out of the total. So what we could do is if we just focus on Angel Cruz, that's 483 votes out of, again, this 6,424 is the total. So it's really 483 out of the total 803. should equal however many Angel Cruise is expected to win out of the total. This one's just pretty simple cross multiplication. So I would just, if you multiply these together, you're going to get just some big number. And if you multiply these two together, you're going to get 803x. So it's really going to be just this big number divided by 803. So I'll find that in the calculator. So it's 483 times 6424, 6,424. And then you'll divide that by 803, and it gives you 3,864.
All right, makes sense.
Good. Okay. And the third one. All right, so a grove has 6 rows of birch and 5 rows of maple. Each row of birch has 8 trees, 20 feet or taller, 6 trees shorter than 20. Each row of maple. Okay, so they give us a bunch of information. So a tree from one of these rows will be selected at random. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? So if it's given that the tree is 20 feet or taller, the denominator, so this is conditional probability. The denominator is only the trees that are 20 feet or taller. We're not looking at all of the trees. Um, okay, so what I'm going to do is highlight that. So I have 8 trees, 20 feet or taller, that are from the birch. So that's 8 times 6. All right. So again, if we just look at the birch, each row of birch has 8 trees, 20 feet or taller, and there's 6 rows. So that's a total of 48 trees in of the birch trees that are 20 feet or taller. Then I want to go to the maple trees. There are 5 rows of maples, and each row of maple has 9 trees that are 20 feet or taller. So that's 5 times 9, that's 45. I just want to make sure I did that right. Yeah, so each row of maple, there's 5 rows, and there's 9 trees that are 20 feet or taller. So 48 plus 45, which obviously we can find pretty easily. That's 93. But I want to keep them separate right now. So again, if we know the tree has to be 20 feet or taller to begin with, then it's only these 93 trees that we are actually care about. And it wants the probability of selecting a maple. Well, I kept these separate because the ones that were maple were the 45. So that's what goes in the numerator. So out of the 93 trees that are taller than 20 feet, 45 of those are maple. So it's just, and then what you could do is 45 over 93. So this is how I did it. I would do 45 over 93. You have to reduce that, but instead of like wasting time reducing it, in the TI-84, if you just do this and then hit math, enter, enter, it'll reduce it for you and it'll tell you that that's 15 over 31. I mean, it might not be hard to realize you divide by 3, but rather than even do that thinking, when you reduce fractions, I would either use the TI-84 or just throw it into Desmos, and there's like a button to click on the left side that'll reduce it for you.
All right, understood.
Okay. Yeah, that one, that was a really hard problem. That usually these conditional probability problems are they like give you the table, the two-way table, but this one, the way that they just like explained it made it a lot more difficult to do. Okay. Um, all right, so those were all the submitted problems. That I have others that we can kind of do with just a couple of little themes here and there.
All
Um,
right,
So these ones coming up all have to do with the idea of area, but they have to do with this idea of using scale factors. So here, these ones I'll give you a little bit of time. So try number 4, and then we'll go over it in a minute and a half. Okay. So the point of these problems is to do them, I mean, any problem is to do as quickly as possible. But here, they give us the area of a triangle, and a lot of times our brain goes to like, oh, the area of a triangle is 1/2 base times height. But what I want to do is I want to try to do this without using that formula at all. Um, so if we look, and I'm only doing this to just kind of get a visual, you don't need to do this. Let's say the area of this triangle is 14. Um, and then some second triangle, we're trying to find the area of that. Well, if the second triangle has side lengths that are 8 times those of the first triangle, what that means is it has this thing called a scale factor. And the scale factor is 8 because any single dimension gets multiplied by 8. So in general, scale factors are what any single dimension gets multiplied by, like length, width, height, radius, anything like that. Even perimeter is anything will be measured in a single dimension. That is what each of the dimensions get multiplied by. Now, what happens is when you want to see what the effect that has on the area, so this is always true, the area is always gets multiplied by the scale factor squared. Because think of area is like measured in square units. So if we that means that the area now is going to get multiplied by 64 because the scale factor is 8, so the area gets multiplied by 64. So again, I do more like explaining than just to, go over the concept. But really, this problem, all you need to do is 14, the scale factor is 8, so the area gets multiplied by 64. So you just got to do 14 times 64. And that is simply just 896. And
All
that's
right, makes sense.
good. Yeah, so what I've seen before is students picking their own numbers to get 14 here and then multiplying each of those by 8 and then finding the new one, which will work. But again, it's really a lot easier to just kind of look at it from this perspective. So let's take a look at another one. Okay, so this one is actually an example where what I had said before doesn't necessarily work. Um, there is a way to do it that way, but I'm going to actually do this one a different way. So the reason that it's not a scale factor problem, all right, is because it says only the radius changes and it doesn't say the height changes. So in order for a scale factor to work, all of the dimensions would have to be changed by that same number. Um, so I'm going to show you two different ways to do this one. So the kind of the I guess logical way to go about it would be if I want the volume of a cylinder, that is given on the reference sheet. It's just pi r squared h. And I'll call this like volume one. So the original cylinder is just um, if the radius is 4, so 4 squared is 16, and the height is 6. 16 times 6 is 96. So we're starting with 96 pi. All right. And then if I want to find the second volume, well, now I have to increase the radius by 50%. I would increase something by 50% just simply by multiplying by 1.50, and that gives us 6. So now our radius is 6, but our height doesn't change. Our height is still 6. So now I have 6 squared times 6, which is 216. So now I get 216 pi. All right, so that's the new volume. All right. And then what I want to do is figure out how much it changes. So what I like to do in these is just simply divide them. So do 216 pi divided by 96 pi, and 216 divided by 96 is 2.25. And what that means is, so if I jump back to here, The reason I multiplied by 1.50 was because it's a 50% increase. So it's zero point 0.5 plus 1. Well, if I do the opposite of that, if I think, well, what did I add to 1 to get to this? That would be 1.125, which is 125% larger. So the answer is D.
All right, that makes sense.
Good. So now I guess the quick way to do it would be we can kind of use the scale factor, but instead of thinking of it as volume, which will be three-dimensional, since the height doesn't change, if we kind of ignore that, we can say that the scale factor, or what the radius is being multiplied by, is 1.5. And since the radius is being squared, then k squared just gets us directly to 2.25. And again, we have to know that 2.25 really represents a 125% increase. So there is a way to just do it. It's just tricky because typically volume you would do k cubed, but we don't here again because the height stayed the same. So we really only mess with the radius, which is what got squared. So if that second one would be the quickest way to do it, but if that's confusing, just do it this way, where you find the original volume, find the second volume, and then figure out that it's 125% larger.
All right, got it.
Okay. Okay. So another one, where this one is another one with scale factors. Okay. This one's a little bit more challenging, but again, if we try to use the formula for a cone, I feel like that just makes it even more complicated. So what we want to again realize is K is the scale factor. So I'm going to write this out, which we don't know. Then the area, anything to do with area, is going to get multiplied by K squared, which again, we don't know that. And then whatever the volume gets multiplied by, that's going to be the scale factor cubed. That we can figure out because if the volume goes from 125 to 216, if I divide them, I can figure out what we were multiplying by. So I can do 216 divided by 125, which is 1.728. And just use a calculator for that. So that means to go from the one volume to the other volume, you're multiplying by 1.728. But what that is the scale factor cubed. So I'm just going to do the cube root of this. And if I do the cube root of this, that's going to give me k. And again, in the calculator, the cube root of this number is 1.2. So that means the scale factor is 1.2. So the area must be multiplied by the scale factor squared. So if you square 1.2, you get 1.44. And then the way I can use that is if the base area of the smaller cone is 25, that must be multiplied by 1.44 to get the base area of the larger cone. So finally, we just do 25 times 1.44, and you get 36.
All right, understood.
Good. All right. And we'll do one more scale factor problem. All right. So again, when we see the word similar, that tells us that we're likely going to be able to use this idea of scale factors. So the area of parallelogram A is 27 times the area of parallelogram B. So that means if I go from B to A, and this is the area, I would be multiplying by 27, which means the scale factor squared, k squared. I've just been using k for the scale factor. So the scale factor squared must equal 27, which means I can just solve for k. right for right now, I'm just going to say that's the square root of 27. And then the length of the longest side of B is 7 inches. What's the length of the longest side of A? So again, the scale factor is what I'm multiplying each side of B by to get A. So what I'm going to do is I'm just going to take the 7 and I'm going to multiply by root 27. Now, this problem doesn't tell us how to round. So I'm just going to do that in the calculator. And then remember that whenever you're putting in an open-ended problem like this, they want you to use 5 characters. So I got 36.373. So I'm just going to stop it at 37 because the decimal counts as a character. So this is what you would enter. Um, Again, when they don't tell you how to round, you want to use 5 characters.
All right.
Okay. All right. So that one's good. No questions.
Yeah, understood.
Okay. Okay. So then the other type of problem that I picked out had to do with percentages. So again, I'll give you a minute and a half to try this one. All right, so we have the percentage. I mentioned it earlier, it just happened to show up in the geometry problem. Um, but what we want to do is typically with percentages that are related to percent increase or decrease, you want to find like the single number that we should multiply by. So we're gonna imagine that we have something that costs, let's say, like X. We don't know what it originally costs because it wants the original price. And then we want to think about it. We're going to multiply that by some number to represent a 20% discount. So a discount is a decrease. So we can think about it as if you start with 100% and you take away 20%, you have 80% that remains. So if we multiply by zero point 0.8 or maybe 0.80 will be easier for you to like see the 80. That's what we multiply by to give us a 20% discount. Um, that's a way to multiply it by like one single number. And then a 9.5% sales tax. Well, a tax is an increase. So that's where you do 100 plus the percentage. So that would be like 109.5%. And in decimal form, that's 1.095. So this is the number that represents a 20% discount. This is the number that represents the 9.5% sales tax. And in the end, that equals K. So if we think about the way that we would get the original price by itself in terms of K, it would just be K divided by these numbers. So that gives us C. And that, oh, my bad. That is not right. The answer is A. I just looked at the wrong one. So then it leads to kind of if you understand that, then there's a bit of a quicker way to do it. So just realizing that a 20% discount is related to zero point 0.8 and a 9.5% discount is, or sorry, the sales tax is related to 1.095. That eliminates B and C right away because the zero point 0.2 is wrong and the 0.095 is wrong. And then um, if they give you the original, then you're multiplying by those numbers to get the final. So if they're looking for the original price, then you're going to be dividing to get the answer. And if they're looking for the final price, you would be multiplying to get the answer. So that's why it might be a quick to just get A without even having to write this out. Any
Good.
questions?
That makes sense.
All right, good. So let's keep going with a couple more tonight with percentage problems. Okay, so we initially have 200 bacteria, and in the first hour, it increases by 10%. So again, if we're starting at 100% and increasing by 10%, that means we're taking 110% of it, which really is just the decimal 1.1. Or again, I'll put the 0 just so we can like see the 10 there. So this would be after the first hour. And then each subsequent hour, it increases by 5%. Well, increasing something by 5% would be 105% of it. So that would be like 1.05. But we want it after 8 hours. So if it happened like this for the first hour, then it would happen this repeatedly for 7 more hours. That just becomes an exponent because it's like we're multiplied by 1.05 over and over and over again. So this is the setup. You just put that in the calculator and it's like 309.56. Um, and they just went to the nearest um, integer. So that's just 310.
All right. I understood it.
Good. All right, they're just going to do a couple more. So let's try this one. Just a couple more percentage problems. All right, so this is along the lines of the other one, but it does have something in here that is a pretty common mistake. So let's just to have something to work with. Again, you could do this in a quicker way, but just have something to work with. Let's say we start in 2015 with a sum amount. It doesn't really matter, so I'm just going to call that X. And then she spent 76% more in 2016 and 2015. So that means in 2016, to go from 2015 to 2016, we multiply by 1.76. So as we said before, the way you increase a percentage is you add the percentage to 100 and then change it to decimal form. Now, this is where we have to do that again. She spent 145% more on groceries in 2017. For some reason, when it's a percentage over 100, students make the mistake of just doing 1.45. But that is incorrect because it's again, doing nothing is 100% because 100% is like multiplying by one. So if you start with 100% and increase by 145%, then you're going to end up with 245% of it, which is really multiplying by 2.45. And if Sim spent P times as much on groceries in 2017 as 2015, then whatever we're multiplying by overall is P, and that's just these two multiplied together. So this part here is like P. So all we have to do is just multiply them together, and you will get 1.862. So the amount that she spent in 2015 in the end gets multiplied by 1.862. So that's why the answer is B. If you use 1.45, that's going to give you A. So that's why that answer is there. Because again, when we see this, for some reason, we forget to add the 100%. That's something that I see a lot.
All right, got it.
Okay. All right. So the last one that I had, I think I have one more here. Yeah, that was the last one that I had is so we'll do one more with these percentage type problems. Okay. So here's how I'm going to do this one. Based off the concepts that we were talking about earlier, I'm going to just turn each sentence here into an equation. So the price of X is is always equals 25% greater than Y. Well, 25% greater is again, doing nothing is 100%, increasing by 25% is 125%, and in decimal form, that's 1.25. So you get 1.25Y. Then if I go to the second sentence, Z is 25% less than Y. Well, 25% less would be starting at 100, take away 25, and you get 75% of Y. So that's 0.75 Y. And then what is the ratio of price of X to Z? A ratio is just another way to look at a ratio is a fraction. That's just X over Z. So a nice little shortcut we can take here is we're allowed to divide these equations, right? X over Z would give me X over Z, and then I can just divide these. So the Y's will cancel, which is good because they want X to Z and there's no Y in any answer. So Then I need this. So again, what I would do is either use Desmos or the TI-84. I'm going to use the TI-84. Is I'm going to literally type in 1.25 divided by 0.75. And then I'm not even going to hit enter to figure out what decimal that is. I'm just directly going to hit math, enter, enter, which will just change it to a fraction and reduce it as well. And you get 5 over 3, which is just the ratio 5 to 3. So that's what I think is like kind of the quickest way to do it, to set these up, and then just you can quickly just divide these. And definitely use calculator or Desmos to help you out, so you don't have to like waste any time with any other like decimals or any converting on your own.
All right then.
Cool. Okay, so any questions, or were there any other problems that you had questions about to submit or anything else?
No, I think I understood it all.
Okay. Cool. Well, that's all I had, so we can just stop there for tonight.
All
So
right.
just make sure again to submit whatever problems you want, and I'll just hopefully see you next week.